Hello students. Hope in these trying times of COVID, you're all safe and healthy. I'm Dr. Seema Singh and you're watching my channel Bonding with Chemistry. Today we will continue with part 8 of chapter 3 Metals and Non-Metals. This is the list of topics that I've already covered in my previous videos. In today's video, we'll continue with the fourth chemical property of metals, their reaction with solution of other metal salts. My dear students, if you remember, you have already come across this topic in chapter 1, Chemical Reactions and Equations, under the subheading Displacement Reactions. The link for your reference is provided on top of this video in the info section. In my upcoming video, we will learn how metals react with non-metals. So don't forget to subscribe to my channel and do press the bell icon for receiving the latest notifications. On the basis of metals reaction with oxygen, water and acids, about which we learned in my last 3 videos respectively, we arranged metal samples in decreasing order of their reactivities as shown here. This was the order we obtained when we reacted metals with oxygen, this one with water and this one with acids. And from all these reactions, we concluded that reaction of metals with oxygen, water as well as acid could not help us in providing a clear-cut reactivity series. And why so? Because not all metals reacted with oxygen, water and acids respectively. And we also witnessed that few metals occupied the same slots in reactivity series, as you can see here. So today we will try to obtain a detailed reactivity series by performing various activities that involve displacement reactions. Before we take up these activities, let us quickly brush our knowledge about displacement reactions with the help of an illustration. As already stated, for greater details, you can always refer to my video on displacement reactions. Let us say we have two friends B, C, both share good bond of friendship. After a while, let us say a person A comes into picture. Now A being more smarter and intelligent than B is able to break this friendship bond and kick out B and take its place. You see here? So A and C are friends together and poor B is left out. The same thing happens in a displacement reaction whose general equation can be written like this. Here we have a compound, say BC, in aqueous form. Now by aqueous form, I mean BC is a solid compound and we dissolve it in water. So the resultant solution you get is known as aqueous solution. We can also have BC in molten form represented by L. By molten form, I mean the compound BC is melted so that it exists in liquid state. Now, a displacement reaction is a reaction in which a more reactive metal, let us say A, displaces or replaces, or if in case I have to use a little rough language, kicks out a less reactive metal from its salt solution to take its place and form AC compound, and poor B is kicked out or left out. Coming to the definition of displacement reaction, which is also known as single displacement reaction, we say a reaction in which an element displaces another element from its compound. And what should be the important thing you need to remember? That this compound should be either in solution form or molten form. Now let us try to understand how displacement reactions can help us in arranging the metals on the basis of their reactivities. For this we will undertake a couple of activities. The first activity that we will take is from NCERT. The activity is reaction of metal samples with solutions of other metal salts. Suppose we have two metal samples, iron and copper, and we need to decide that out of these two, which is more reactive. Although by now you would have a fair idea that iron is more reactive than copper. You witnessed that in the last three videos. But still let us find out with the help of this activity. So for this activity, you're supposed to take an iron nail and a copper wire or a copper strip. We will keep one of the iron nail and one of the copper strip as a reference. Now dip the iron nail in the aqueous solution of copper sulfate and copper wire in the aqueous solution of iron sulfate respectively as shown here. You can see in this figure that copper sulfate is light blue in color, whereas iron sulfate is light green or apple green in color. Thereafter, leave both the setup undisturbed for some time, let us say 20 minutes. What will you observe? In setup 1, you will observe that copper sulfate slowly turned light green in color and the surface of the iron nail had brown color deposition on it. You can compare the iron nail with the reference nail. The observation suggests that a reaction has taken place, whereas in the second setup, no change was observed, suggesting no reaction took place. Let us now explain the reason behind the above mentioned observation. For setup 1, the corresponding equation can be written as Fe plus CuSO4 give rise to FeSO4 plus copper. Here, iron has displaced copper from its aqueous solution copper sulfate and you get iron sulfate. Now this iron sulfate, also known as ferrous sulfate, is light green in color as you can see here. And the reddish brown color deposit that you see on the iron nail is because of deposition of copper which is kicked out or which is displaced from this solution. Whereas if you look at setup 2, copper has not been able to displace iron from its salt solution and hence no reaction was witnessed. All this suggests that iron is more reactive than copper and hence should be placed above copper in the reactivity series. Let us consider some more examples. If we take copper and silver metals, say in the form of thin strips or wires, and place them in the solution of silver nitrate and copper sulfate respectively. Here silver nitrate is colorless whereas copper sulfate is light blue in color. We will observe that after some time in setup 1, the colorless solution of silver nitrate has slowly changed to light blue color due to the formation of copper nitrate and a shining coating of silver metals get deposited on the copper strip. The corresponding equation for the reaction can be written as copper reacts with silver nitrate to give rise to copper nitrate, which is light blue in color, plus silver metal gets deposited. Whereas in setup 2, no change was observed, suggesting no reaction took place. Thus, we can conclude that copper being more reactive than silver was able to displace silver from its salt solution, but silver was unable to displace copper from its solution. So copper should be placed above silver in the reactivity series as copper is more reactive than silver. Similarly, if we consider zinc and copper metals dipped in blue color solution of copper sulfate and colorless zinc sulfate solution, we observe after some time that zinc displaces copper and thus turning the blue color solution into colorless zinc sulfate solution. Also, the displaced copper deposit on the zinc metal strip. The corresponding equation for the above reaction can be written as zinc plus copper sulfate give rise to colorless zinc sulfate plus reddish brown color copper metal. No change or reaction is witnessed in setup 2, which proves that zinc is more reactive than copper and should occupy a higher place in the reactivity series as compared to copper. Taking one last example, say that of zinc metal and iron metal and dipping them in light green color ferrous sulfate and colorless zinc sulfate solutions respectively. We will observe that zinc displaces iron from its solution, turning it colorless. Also, the displaced or precipitated iron deposits around the strip of zinc metal. The corresponding equation for the above reaction can be written as zinc plus FeSO4 give rise to colorless zinc sulfate plus iron metal, whereas no change or reaction is witnessed in setup 2, which proves that zinc is more reactive than iron and therefore should be placed higher in the reactivity order as compared to iron. Thus, from all these activities, we can conclude a simple rule of displacement reactions, which is when a more reactive metal is placed in the salt solution or molten form of a less reactive metal, then the more reactive metal displaces the less reactive metal. So, based on the result of these four activities, we can arrange the metals iron, copper, silver, and zinc in decreasing order of reactivities as follows. Zinc, the most reactive metal, followed by iron, copper, and silver. You can see here. We see here zinc displaces both copper and iron, right? So zinc will find the first place. It displaces both iron and copper. But out of iron and copper, who displaces whom? We see iron displaces copper. So iron is placed on number 2. Now the remaining are copper and silver. We see copper displaces silver. So copper occupies number 3 and the last spot goes to silver. My dear students, similarly by conducting several sets of displacement reactions, we can ultimately build or arrive at the detailed reactivity series of metals. So on the basis of reactivity of different metals with oxygen, water, acids, and finally displacement reaction, the chemists have been able to arrange the metals in order of their decreasing reactivity. And this series, as we all know, is known as the activity series or the reactivity series. Students note that this series is more exhaustive with more metals, but here we will consider only those metals which are helpful for a present class level. This series is important and you need to learn this series because it is going to help us in predicting whether a reaction will take place or not. I've already provided few mnemonics in my previous videos which will assist you in learning this series. You can refer to the link above or choose any other mnemonics created by you or which are available online. You may note that although hydrogen is not a metal, yet it occupies a place in the reactivity series. This is due to the fact that number 1, like metals, hydrogen can lose electron and form a cation. That is, hydrogen can lose an electron and form H positive ion, which is known as proton or hydrogen cation. Also, hydrogen is placed for comparing the reactivity of metals with respect to it. All metals that are placed above hydrogen in the activity series, for example, your potassium, sodium, lithium, calcium, all these, they can lose electrons more readily than hydrogen and are more reactive or active than hydrogen. Whereas the metals that are placed below hydrogen, namely copper, silver, gold, and platinum, can lose electrons less easily as compared to hydrogen and are treated as less reactive metals as compared to hydrogen. Dear students, you need to remember the following key points about displacement reaction. Number 1, elements that form cations, for example metals. Metals will lose electrons and form positively charged ions and therefore those ions are known as cations. A cation is going to replace or displace only cation. You can see here copper, which is a metal. Here in silver nitrate, Ag is a metal. So copper can lose electron and form cation and silver exists as cation here. So copper can displace silver and not nitrate because a cation is going to displace cation from its salt solution. Now the second point is quite familiar to us. A more reactive metal displaces the lesser reactive metal. Well students, this video deals with both these points. Such displacement reaction involving displacement of a metal by a more reactive metal is also known as metal displacement reaction or metal replacement reaction. Coming to the third point, elements that form anions. For instance, who form anions? Halogens. Halogens are represented by X, which can be fluorine, chlorine, bromine, or iodine. We have acetine also, but we are going to talk about it later. Now, anions can replace anion in a compound. For example, you can see here, when chlorine is passed through sodium bromide solution, it is going to displace the anion bromine, not the cation sodium, to give rise to NaCl plus Br2. Well, student, this point is currently not in your syllabus, but I did explain it in my video on displacement reaction. In case need be, you can check that out. Let us solve a couple of problems by taking the help of reactivity series. The question says, which of the following displacement reactions can take place? Write balance equations for reactions that are possible. So we have set 1 and set 2. Let me do set 2 for you. In set 2, we have two reactions, Ag plus copper nitrate, and the second one is copper plus AgNO3. We need to find out of these two reactions which will take place, and the one which is going to take place, we are going to write the complete balanced equation for it. See, we have two metals, silver and copper. Now, if you look at the reactivity series, now in examination, you're not going to get the reactivity series. Probably by that time, you must have learnt the reactivity series or memorized the reactivity series. Now, here we know copper is placed above silver. So, copper can displace silver from its aqueous solution, but vice versa is not possible. So, copper can displace silver from its aqueous solution, but this is not possible. So this reaction is possible, and when copper is going to react with silver nitrate, you're going to get copper here, NO3 whole twice. This is known as your cupric nitrate or copper 2 nitrate. This is going to be aqueous and silver metal is going to be knocked out, right? Remember to balance the equation. So we have copper here and we see this part is not balanced. We put a prefix 2 and we have a balanced chemical equation. In case you need to brush up your balancing concept, do refer to my videos on balancing of chemical equations. I would suggest you pause the video, solve the first part and then check your answers or match your answers with mine. So here we have two metals, magnesium and zinc. Magnesium is placed higher as compared to zinc. So magnesium can displace zinc from its aqueous solution, but this is not possible. So the first part or the first reaction is possible. Magnesium is going to displace zinc and you get MgSO4 aqueous and zinc is precipitated out, which will be in solid form. Here silver will be also in your solid form, right? Just check the balancing. This is already balanced equation. Coming to the second part, this is not going to take place. You can either put a cross there or write no reaction. I would suggest you write no reaction. Now let us go through few more points highlighting the importance of reactivity series. We just learned how reactivity series help us to predict whether a metal will be able to displace another metal from its salt solution. That is, it helps in predicting the reactivity of a metal with respect to another metal. For example, if I ask you out of calcium and aluminium, which is more reactive, we'll say calcium is more reactive as compared to aluminium as it occupies a higher slot in the reactivity series. This series also helps us to decide whether a metal will be able to displace hydrogen from its compounds such as water and acids or not. We learned that in my previous videos that metals that are placed above hydrogen can displace hydrogen from its compounds like water and acid as they are more reactive than hydrogen. For example, magnesium plus hydrochloric acid. Now magnesium is placed above hydrogen in the reactivity series. Therefore, magnesium can displace hydrogen from its compound in aqueous form to evolve hydrogen gas and the corresponding salt is formed. Whereas the metals that are placed below hydrogen cannot displace hydrogen from its compound as they are less reactive than hydrogen. Reactivity series also gives us the information about the state in which a particular metal occurs in nature. For example, elemental potassium does not occur in free state in nature because of its high reactivity, as can be seen by its higher position in the reactivity series. It is found in combined state such as ionic salts, potassium chloride, potassium nitrate, etc. Whereas metals such as gold, silver, platinum do occur in free or native state as they are least reactive metals occupying the last position in the reactivity series. Let us also have a look at an important use of displacement reaction. During the metal displacement reaction, we often receive the metal which is displaced or kicked out in pure form, and this can be helpful especially if we want precious metals from their salt solutions. For instance, we can obtain solid silver from its solution silver nitrate by adding copper metal to it. So when you add copper metal to silver nitrate solution, copper being more reactive is going to displace silver from its salt solution. Isn't that interesting? Let us now try and find out the reason for different metals showing different reactivities, or the basis of the reactivity series at atomic or electronic level. The reason is the variation in tendency of metals to lose electrons, which is known as the electropositive nature. A metal that has greater tendency to lose electrons to form positively charged ions will be able to react faster with other substances and thus will be placed higher in the reactivity series. On the other hand, if a metal loses electrons less readily, its reactivity will be less and it will find a lower place in the reactivity series. We have learned that metals such as sodium and potassium react vigorously, rather explosively, with substances such as oxygen, water, and acids. This is because they can readily or very easily lose their valence electron. For example, potassium, if you remember, has electronic configuration of 2881. It can readily lose the one valence electron to form positively charged ion, also known as potassium cation, with configuration 288 plus one valence electron, right? Whereas metals such as copper, silver, gold, and platinum do not lose their valence electrons easily and are hence quite unreactive and placed at the bottom of the reactivity series. Let me explain this with the help of the first activity we undertook in this video. Remember? Iron nail and copper wire dipped in copper sulfate and iron sulfate solutions respectively? Now in the first setup, solid copper sulfate when added to water form copper sulfate solution. What I mean is, how you're going to form this copper sulfate solution? You will have copper sulfate in solid form, and when you're going to add it to water, it will dissolve and you will have copper sulfate solution or aqueous form of copper sulfate. So this blue color solution is your aqueous copper sulfate solution. Now in aqueous form, your copper sulfate solution dissociates into copper ions, positively charged copper ions, cations, and negatively charged sulfate ions known as sulfate anions. I'm only showing one copper ion and one sulfate ion for the sake of clarity. Otherwise, there are going to be millions of cupric ions and sulfate ions in the solution of copper sulfate. Now, when iron nail is dipped into this solution, what is this iron nail made up of? Iron atoms. So, you have plenty of iron atoms making up your iron nail. So, in this setup, we have two metals, one iron and the other is copper. Now, if you remember the reactivity series or you look at the reactivity series, you will see that iron is placed above copper, which means iron is more reactive as compared to copper, or it has more electropositive nature as compared to copper, or it can easily lose electrons as compared to copper. So, this iron readily or quickly wants to lose electron and form Fe2 plus ions plus 2 electrons because iron is having more electropositive nature as compared to copper. So this Fe loses 2 electrons and forms Fe2 positive ion, right? Now copper 2 plus is going to take these 2 electrons and convert into copper metal, and this copper metal is going to deposit slowly on this iron nail as reaction is going to proceed. The remaining Fe2 plus ion, this is positively charged ion, it will get attracted to the negatively charged ion which is sulfate ion, and it's going to form FeSO4, which is light green in color, and slowly as the reaction proceeds you will see the blue color will fade away and you will get light green color due to the formation of ferrous sulfate, and the copper metal will slowly deposit on the surface of iron nails. Whereas in the second setup, when you add copper metal to ferrous sulfate solution, we see no change because copper, being less electropositive than iron, is not interested in losing electron. Copper is happy. I don't want to lose electron and convert it to copper 2 plus ion. Similarly, FeSO4 means iron is present in the form of Fe2 plus. It also doesn't want to take electrons and convert into iron, and hence you see no reaction taking place. Dear students, finally let us put to test what we have learned by answering the following questions. The question says samples of 4 metals A, B, C and D. My dear students, don't get bogged down or worried by simply looking at the length of the question. This question is pretty simple, and if you are able to solve this question, it means whatever I have taught you in this video is absolutely clear to you. Coming back to the question, samples of 4 metals A, B, C and D were taken and added to the following solution one by one. So you have 4 salt solution, namely iron sulfate, copper sulfate, zinc sulfate and silver nitrate. The results obtained have been tabulated as follows. In the form of the table, the results have been put. Use the table above to answer the following questions about metals A, B, C and D. The first part is, which is the most reactive metal? Now, in order to answer this question, let us arrange the metals that are involved in the salt solution in decreasing order of their reactivity. What does it mean? Now, here in these 4 salt solutions, you have 4 metals, iron, copper, zinc, and silver. Let us arrange them in decreasing order of their reactivity. And for this, you need to know the reactivity series. Now, as far as your class level is concerned, a simple mnemonic magazine FECA, I through the magazine, like this. Magazine, aluminium, magazine, FECA. So you see here, magazine, M-A-Z, magazine, FECA, F-C-A. Now, if you remember this mnemonic, you will be able to solve most of the questions that come across for your class level. But still, on the safer side, you need to remember the exhaustive list of metals in decreasing order of their reactivities. Right? Now, here we have iron, copper, zinc, and silver. So we don't require magnesium and aluminium. So if you look at these 4 metals, we see zinc is the most reactive, followed by iron, copper, and silver. Coming back to the question, which is the most reactive metal? Can I say the most reactive metal will be the metal which will be able to displace zinc from its salt solution? Because zinc is the most reactive metal. Let us look at the table and find out. We see that no metal has been able to displace zinc from its salt solution. Then what do? We move on to the next metal, which is iron. Let us find out, has any metal been able to displace iron from its salt solution? So you have iron sulfate here. We see A, C and D show no reaction with iron sulfate, whereas B displaces iron from its salt solution. And therefore we can say B is the most reactive metal. Coming to the second part, what would you observe if B is added to the solution of copper sulfate? Now B has been able to displace iron. So can I say B will be also displacing copper from its salt solution because copper is placed below iron in the reactivity series, or copper is less reactive than iron. So if B is able to displace iron, obviously it will be able to displace copper from its salt solution also. Coming to the last part, which says arrange the metals A, B, C and D in the order of decreasing reactivity. Here we already know B is the most reactive metal. You have to arrange in decreasing order, remember, from biggest to the smallest, or the most reactive to the least reactive metal. Now B has been able to displace iron from its salt solution. Let us find out the next most reactive metal. The metal which will be able to displace copper will be the next reactive metal. Let's see. If you look at copper sulfate, A has been able to displace copper. B obviously will be able to displace copper. So after B, the next most reactive metal is A. Now we are left with C and D. Now C and D show no reaction with iron sulfate, no reaction with copper sulfate, and no reaction with zinc sulfate. But C displaces silver from its salt solution, whereas D still shows no reaction. So I can say C is the next most reactive metal, followed by D. D shows no reaction with iron sulfate, copper sulfate, zinc sulfate or silver nitrate, and hence is the least reactive metal. So the decreasing order of reactivity is B, A, C, D. Moving on to the next question. The question says, what would you observe when zinc is added to a solution of iron sulfate? Write the chemical reaction that takes place. So we need to know again the reactivity series. Let us see if the mnemonic Maxine Feka helps us in solving this question. So the mnemonic is Maxine Feka. So we have zinc and iron. Zinc is placed above iron in the reactivity series. So zinc is going to displace iron from iron sulfate solution, which is light green in color, and you will obtain zinc sulfate solution plus iron will be precipitated out. You can see the reaction here. Zinc reacts with ferrous sulfate solution, knocks iron out to form zinc sulfate, which is colorless, and iron is precipitated or deposited. Coming to the next question, which of the following pairs will give displacement reaction? Again, my dear students, you need to know the reactivity series to solve this question. Let us again see if the mnemonic Maxine Feka helps us in solving this too. The first part is NaCl solution and copper metal. Now, sodium has not been the part of this mnemonic, but we all know sodium is very reactive metal as compared to copper. So, copper cannot displace sodium from sodium chloride solution. This displacement reaction will not take place. Magnesium chloride solution and aluminium metal. Aluminium is placed below magnesium, and therefore aluminium cannot displace magnesium from its salt solution. Moving to the third option, ferrous sulfate solution and silver metal. Now silver is placed below iron and therefore silver cannot displace iron from its salt solution. So when this possibility is not there, the last part is silver nitrate solution and copper metal. Copper is more reactive as compared to silver and will be able to displace silver from its salt solution. Therefore, this pair will give displacement reaction. So the correct answer is D. With this question, I come to the end of this video. If you liked my video, do please spare a moment and give it a thumbs up. In my next video, I'll take up the reaction of metals with non-metals. So stay tuned to my channel, don't forget to subscribe to it and share this video with anyone who you feel might benefit. Thanks for watching and until next time, take care and stay bonded, my dear learners.